Hello everyone and welcome to Reentry. Given the day today and the anniversary of the Boctok 1 flight, I wanted to kind of spend some time in Reentry and perform a similar flight myself. This is going to be using some unreleased bits. I've never released Vostok anywhere outside of my own hard drive before. I did show it off briefly at my 0.75 update that rolled out something called TSS for Apollo. TSS stands for the Truth Scale System and is basically an upgrade of the game engine in Reentry. It's an integration layer between the physics engine and the rendering engine. But I'm not going to go through all the TSS things today. Today I'm going to talk about Vostok and the Vostok 1 flight. So you can see up here that we're now on the 12th of April 1961 and we're a couple of minutes away from ignition. So this is the rocket, and if I now jump into the cockpit, you can see that there's a couple of things in front of you. First of all, Boctok had two main panels. One was called the control panel, and you can see it here. It basically has a lot of control switches and ways to interact with the different systems on board. And then you had the main panel, which has the entire signal light array, in addition to some indicators, a watch, globe view, and so on. In addition, there's a couple of other systems located around the inside of the cockpit that I'll basically go through as we ascend and get into orbit. So Vostok was a quite short mission. It was the first manned mission in space ever, and it lasted for a duration of about one orbit. Today we will be ascending into orbit on this rocket. It basically has a few stages. It has 4 strap-on stages surrounding a core stage in the middle, and then it has a lunar stage that will take the entire spacecraft the last bits into orbit. We'll go through some of these things that as we start ascending and getting those engines ignited. So before we do anything here, I wanted to just highlight one of the really cool things about Vostok, and that's how automated it all was. I know that probably a few of you have been trying to fly the Mercury space capsule here in Reentry, or maybe even in other simulators as well. And the Mercury capsule and Vostok are quite similar in some ways, but then again very different in other ways. We'll go through a few of these systems once we get into orbit and some of the major differences. But one of the things that we can say about Vostok is that a lot of the systems and a lot of the operations here are fully automatic. So you could basically fly this entire mission fully automatic if you wanted to. But of course we're going to do some manual overrides, and we're going to take a deeper look into some of these systems as the mission proceed. But one of the things that you can do before ignition is to do a lamp test. So you can just click this button and it will toggle all the light bulbs inside of this main panel on, and you can verify that everything seems to be functional. There's no indicators that has text but with no lights, and yeah, everything seems to be in order. So now we're about 2 minutes away from launch. I'm going to time scale to about 30 seconds before ignition. Alright, we're 30 seconds away from ignition. And for the ignition, I'm going to start by external view, and then and then I'm going to jump into the cockpit itself. This might be a good view. 12 seconds. Ignition will happen now. There we go. Okay, I'm going to jump in. We can hear the sound of these engines. And there we go. We have lift off. And keep in mind that a lot of these things are bits that I haven't been working on for a very long time. This is not the main priority of reentry, but I do plan, based on the feedback from a previous video, to release this to the public sometimes after reentry has reached the 1.0 milestone. So after 1.0 I'm going to get back to this and start focusing on creating some of these things. But we should now be ascending. If I now kind of jump into the external view, you can see there's a lot of things going on. But you can see that the engines here are now putting a lot of thrust on this rocket and getting this up through the initial part of the atmosphere. About 9 minutes past the hour, these 4 strap-on stages here should separate and do their dancing maneuver, and then the core stage will then continue during the ascent. It's a beautiful, beautiful rocket. Alright, we're getting close to cut off on the 4 outer stages here. There we go. And separation. The core stage will now continue its journey. You can see that there's an outer fairing surrounding most of the spacecraft. If I jump inside now, you can see that the windows are basically blocked except for my rear window that has some view outside. It's quite dark, but you can see that this is the window that you see, and you can see straight up here into space. Right, there goes the fairings, which exposes the Boctok spacecraft for the first time. It's a very different design compared to Mercury, which is kind of a similar spacecraft when it comes to technology, but it does look really, really cool, I think. If we now get in, you can see that the fairings has now made it possible to look through the windows. We can see outside the side view here, and then we can also take a look into the visor, which is just a scope basically. The scope has 2 cameras. One is the center part, which is a zoomed view, and then you have a kind of a fisheye view of Earth surrounding it. We'll get back to that later. The ascent is quite long. I think that we should be doing this insertion at around 17 minutes past the hour. And we're looking at Moscow time here. We do have a watch here. It should indicate a similar time here. So, right, we have staging. That's a core stage heading off. And we're now on the lunar stage here, which will then take the spacecraft the final journey into orbit. The engine is quite small, and the stage itself, but it will do the job. Fine to spend some extra minutes on doing the final push. The watch itself, as I mentioned, does have hours, minutes, and seconds, but it also does have this orbit view here, which shows you where in the orbit you are on the day and night side, and the orbit counter here. We're aiming for a mission of about one orbit today. We'll get into a full orbit around Earth, and then we'll go around the Earth, I think around 70% before we ignite those engines and then get back home. So once I get into orbit and the engines are cut off, I'll spend some minutes on going through most of these switches here and this panel, and I'll spend some time on some of these warning lights as well as these indicators, and then I'll go through these other things on the side here. Okay, we're getting close. Alright, and cut off. Okay, we should now be in space, in orbit, and we have staging. So what's rest of this spacecraft now is this, and you can see that the antennas is now slowly coming out and unfolding and getting ready to have radio contact with the mission control. It's going to spend about 30 seconds to a minute on completing this entire procedure. But as you can see, I didn't have to press any buttons or anything to do that. It was fully automatic. But you do have manual control of the radio and which of these systems you want to use. Boctok had three main radio systems. It had one for UHF and two for HF. The capsule itself, or the spacecraft, the Boctok spacecraft, is split into two different parts. You have the entry module, which is this sphere on top, and this is what comes back to Earth when you do re-entry and landing. And then you have the instrumentation unit or module here, which has a lot of equipment. And you can see that there's some automatic flaps that just opened. These are based on the temperature and pressure inside of this instrumentation unit, and it's an automatic system, but you can monitor this on this panel here. Right now, you don't have too much insight into some of these instruments. You can see that, for example, all of these are on 0. One of the things worth noting is that there's something called a gas analyzer, and that's this switch here. You basically push this all the way down to wind it, and then it will slowly fall back into the start as it does the gas analysis. So if I now zoom out into a little bit fisheye, and you take a look at these indicators here on the tri-gauge, and I click the gas analyzer, you can see that I get a indicator showing that the gas analyzer is active and complete. Usually I press a couple of times on that just to verify, but they seem quite stable. What we're looking at here is that the top part here is the CO2 level inside of the cockpit, and it goes from 0 to 4%. And then you have the oxygen amount, which should be around 21%. And then we have the pressure in atmosphere inside of the instrumentation unit. So these are good indicators to pay attention to, but just remember that you need to update these manually by using the gas analyzer. Luckily it's quite simple, but it's something that you need to do. So sometimes if you take a brief look at this, the values might not actually reflect reality. But the sensors inside of the instrumentation unit here is fully automatic, so it doesn't rely on this data. These will open and close as needed to maintain a set temperature and pressure. The other indicators that we see here is this circle here, which is mostly around the atmosphere inside of the cabin. We have temperature. We can basically modify this here. If I set this to about middle, it should try to keep around 20 degrees. I think that this temperature controller here, it goes from around 10 degrees of Celsius here, and then maximum around 28 to 30 degrees of Celsius here. So I'll just tend to put it in there in the middle, and then the conditioner system will of course try to maintain that set temperature, and you can monitor this here. This one does not need a gas analyzer to function. And then you have the humidity. It should stay at around 30%. And the pressure inside of the cabin. The cabin pressure is also fully automatic, but you do have a warning light here, this one, which shows you a red indicator if the cabin pressure is low, and this is a critical signal, which means that you also hear an alarm sound. This last indicator here is all about our propulsion system. We have three different propulsion systems. You have two for attitude control, and this is manual and automatic control. And then you have the retrograde engine here, which shows the pressure inside of this one. We'll get back to these a little bit later in this in the mission. First of all, we're now currently 0.1 orbit into the mission. This is the orbit counter. It basically goes up with a fraction of precision. So if you've done one orbit, this will indicate 1. If you've done 10, then this one is 1, and then this 0. And this is in between in the orbit, the current phase basically from perigee. Okay, and we're having some sensors going nuts here, but that's fine. That's there's three things here on the signal panel. You have all these green indicators are here in the bottom, and you have some amber indicators in the middle, which is basically just information. And then you have the red signals here, which is something that you need to pay close attention to or even correct immediately. I'll go through some more of these warning lights later, but first I want to spend some time on this panel. This is the control panel, and is your main interface with the systems that you can configure. It has a few things. So I already mentioned the temperature setter here, and then you have the gas analyzer. But down here you have control of the globe. This is the globe view you can see here. This one is not yet fully implemented, but it does work. It's just that I've not been able to program this one yet. You can see that I cannot press this. But this one will be used to configure this globe device along with these two on the side. The globe can be powered, and then it has, so this is basically powering it on or off, so I can turn it on. And then there's another switch here which allows me to select different modes of operation. So this is the orbital position, and then you have the landing position. And an indicator below this one will be illuminated when you set that. But it basically rotates the globe to where it thinks you will land if you would burn right now. But remember, this is a fully mechanical device, and it's not 100% precise, but it can be configured eventually. Going down this panel, we already touched the light test, and this is a brightness a knob for setting the brightness of them. And then you have three switches here which allows you to shut the blinds on the visor and the side window and the rear window. So now I'm going to go here and, for example, close all of them. You can see that we're no longer able to look through the scope, and the windows are also closed. But I'll keep them open for this mission. Keep in mind that this is a visor, so this is the brightness for the visor. You can modify it here, but it's not 100% made yet. And then you have, of course, turning off the visor, but this is a visor, those two. And then these two are for the other blinds. Going down the panel, we have light control. So we can, for example, modify the lighting in the interior. We do have 4 lights. One of them is the TV light in front of you. You can see that it's currently off. And then we have one light here on the side and one in the rear. They're kind of identical. And then we have a bigger, more ambient light here, which illuminates the entire cabin, while these two others are more spotlighty. So The only way to operate them is through this knob here, and this is basically now set to working light, which means that you're now working inside of the capsule. You're doing stuff, experiments, whatsoever you need light. The other thing here is that you can go now into a standby lighting and or night light. So now I can just turn this one down a little bit. You can see that the brightness of those arrows are affected. And then of course you have off lastly, and if I turn on the flashlight I can still see, but you can see that with off it's going to get very dark in the cockpit. So I'm going to return to working light, and then you have the TV light here, and if I now turn this one on, you can see that the TV light is now working and it's illuminating up into the cabin. It's basically to illuminate the astronaut for the TV camera here. But I'm going to turn it off because it's kind of annoying. It's very bright in front of you. The rest of these are for operating the radio itself. You have UHF and HF and some volume things and selectors for the helmet microphone and stuff like that. It doesn't really make a lot of sense for some of these in the simulator, but of course once the radii are properly in place and with this mission system, then this will be a bit more functional, of course. Then you have the side panel. The side panel is protected by this cover, which prevented the cosmonaut to do some of these critical things that you're able to do here. However, they had a code they could use to unlock this thing, and I don't know what's true or not, but I do think that an envelope was given to them with the code so they could open it in case of an emergency or in case they needed it. But the reason for this was that they didn't know how a human would react to being in space. If they would go mad or if something weird would happen, then there would be some procedure required to do stuff that would prevent you from getting back home. The code is 125 in reentry, and this gives us access to all of these switches here. So I can go through each of them. So the first one here is for manual orientation. Right now it's set to auto, but if you switch it up, you have manual attitude control of the spacecraft. Right now it's fully automatic. Then we have the descent mode 3. This is set to enabled, but you can also set it to off. This will enable or disable the automatic entry procedure system. We'll get back to that really soon. If you do disable that, the retrograde engine won't fire, and if we now take a look at the spacecraft itself before we get into the night side, you can see that there's this hole in the bottom, and it's basically where the retrograde engine sits, so it's part of the instrumentation unit. And then you have these thrusters on the side, which gives you attitude control. So this one will just fire that engine manually if you need to. It's a protected cover, so you click it once and it will open. Next you have emergency oxygen and a way to disable the warning signal that will be triggered by some of these things. Once I enter this code, I'm now having access to manually operating the spacecraft, and this is what this amber indicator is telling me. This basically means that I have manual control of not the attitude itself, but of the spacecraft. But if I do want to have manual control of the attitude, I can set this switch to up, which means that I now switch from automatic to manual when it comes to attitude control. And the spacecraft is using a rate command mode for attitude control, and that's the only mode available. It basically means that if I now push the joystick forward, it's going to, from the moment I push it forward, it will take about 1 second before the thrusters will react. So if I now push forward, you can see that you can hear that it took about 1 second. Since this is rate command, and if I now pitch, for example, down again, you can hear that the thrusters are firing. I'm still holding pitch down because that's the direction I want to keep maneuvering to, but once I release the stick, it will try to kill the rates. So that's rate command. It will fire the thrusters until you get up to a predefined angular rate, and then it will try to maintain that rate until you release the stick. Another thing that you can notice is that if I now set this back to auto and you look at the signal lights here, you can say that this indicator in the bottom here tells me that you're in manual mode. So pay attention to this warning light, because you need to be aware of being in manual mode. And the reason for this is that you're going to be re-entering pretty soon, and re-entry is fully automatic if this one is set to up. The automatic re-entry system has 3 indicator lights here. We're now on descent phase 1, and then we have still number 2 and 3 left. So if you now take a look at our timepiece here, you can see that there's this index knob that rotates from 12 o'clock. This is its start position. And once, let's pretend that we're on a 6 orbit mission, for example. Once you get into this last orbit, this indicator will start. And then once it starts, we will get this line illuminated, which means phase 1. Once we cross phase 2, that's this line here, we will enter the next phase of entry preparation. There's some things going on in the background here, but it's all fully automatic, so you don't need to care too much about it. But there's some tests, and then once we get into about 10 minutes before phase 3, which is ignition, it will do some testing of the automatic attitude system to make sure that the spacecraft is able to maintain a retrograde orientation, because you want to do the retrograde burn in retrograde direction, or else you're going to be going in the opposite direction, which will increase your orbit instead of taking you through the atmosphere again. So that's quite an important procedure. This will be functional even if you're in manual mode for even firing the TDU. The only thing that you can switch to manual here, because this is just an indicator basically, and trigger the tests, but if you switch it off, then it won't do all those things. But I'm going to keep it on auto, and I'm going to keep the attitude control on a manual still. I'm going to do a gas analyzer. Okay. Next, I want to take a quick look at the visor. The visor has these arrows that can show you in what direction you need to maneuver the spacecraft. One of the things that you might have noticed relative to Mercury or any of the American spacecraft is that this one is lacking attitude indicators, mechanism to show what attitude you're at. The visor is your tool to be able to do that. It's quite advanced actually. It's simply advanced, to put it that way. If I now maneuver the spacecraft, and I'm going to get into a retrograde direction, you can see from this external view here. We're now on sunset. There we go. A little bit more corrections. Uh, you can see that this thing here is moving around. And the outer part of this scope shows a fisheye view of Earth. And to know that you're now correctly in the roll amount is that if you can get the horizon of Earth aligned around this entire thing, so you can basically see the horizon in every direction. Of course, this is easier when it's daylight. Then you know that your roll is okay. Another thing that you want to be sure of is the direction that you travel. So I'm just going to get into proper orientation here. For example, right now I'm facing in this direction, and there's some arrows here, and you can see that these things on Earth are traveling in the opposite direction of these arrows. This means that I'm facing prograde. So if I now yaw and I start rolling to the side, yawing to the side, I want to do 180 degrees so that I face retrograde instead, because that's the direction I want to burn the engine. And this is just manual preparation for everything. If I stop now, you can see that the direction of the few things that you can still see on Earth in this amount of light is going sideways, so I still have about 90 degrees left. Okay, and then I'm gonna correct roll a little bit. Now you can see that these particles are now traveling in the correct direction relative to the arrows. But if you follow these particles, you can see that they're kind of deviating from these lines. So I can still try to correct my retrograde attitude a little bit more. There we go. We're now facing retrograde, and we're having the last rays of light hitting the spacecraft still in the sunset. Okay, so now we're in retrograde. We should be fine. We still need to correct the attitudes a little bit more probably once we get into the morning side of Earth. Another thing that I want to mention is this thing up top on top here. This was a piece that weren't available on all the Vostok spacecrafts, but I kept it in here because it was still a tool that they used in some of the flights. It shows you your latitude, and by looking at the movements of this, you can see that are you moving towards equator or from it, basically. 0 and is the latitude, and then you have the longitude down here, which is where you are on Earth. This is your coordinates, basically. Another thing that's quite important to know is what these indicators or signals actually means. So I'm going to go through a couple of them, or at least the most important ones. So if we start from the top, the red indicators, when illuminated, of course, if I now turn on the light test, you can see that some of them are red, some of them are amber, some of them are green, as mentioned initially. So the top one here is low cabin pressure. This is that the CO2 concentration is high, and that's this indicator here. And I'm going to do a gas analyzer to update that value. You can see that it's slightly increased, but we don't have anything to worry about yet. This is a short mission. This is to fire the TDU or cancel the descent. This one is gas on first descent. It basically means that you have enough gas to get back. And then you have another one called prepare to catapult. This is something that illuminates after separation from the instrumentation unit, and it means that you need to prepare for re-entry and to leave the spacecraft through that ejection seat. The entry procedures are quite brutal. The sphere will go through the atmosphere, and then it will eject or blow the hatch below here, and then eject this seat and throw it out, and then parachutes will slow the seat down and then release the seat, and you're gonna fall down through a main chute. So that's basically this one. If you see this, get ready to get out. And then this one is to remember to arm the ejection seat, because if you don't arm it, it won't go anywhere, and that could be catastrophic. You have a device here which controls this. This is the power setting, and this is the arm. So if you turn off the power, it won't work at all. If it has powered, you will see the orange light. And then if you turn on the arm switch, which basically arms everything, then you're all ready. So you should see these two lights to know that you're ready for this. This one is if you turn off the tone when a warning comes. And then you have the manual management here. This is your retrograde direction relative to a set angle to the sun. So you have some sensors on the outside of the spacecraft, and this one basically tells you that you're now aligned with those sensors at the correct time, at the correct angle relative to the sun, and if that happens, the TDU is ready to fire. So that's basically how the spacecraft knows that you're at the predefined location of when the automatic system should fire that engine. These green lights here are the descent phase itself. You can remember the lead, we're now in phase 2. And then you have UHF transfer, you have gas analyzer, you have manual orientation. We've already gone through a couple of those. And then you have something called permitted TDU start, which basically means that the TDU is now ready to be started, and you can do that manually here. But remember, you can do that at any time, not only if that indicator is ready. This one just shows that the automatic would fire the TDU, and then so should you if you're on manual mode, basically. So I'm going to turn off the lamp test and then take a look at these side things. So I already touched upon this arming device for the ejection seat. We also have the attitude controller here. You have some shells. I do think that it were quite mission specific on some of these contents and some of the fuses that you could be able to operate in here. And then you have a radio here that you can do things with. You can switch band. You can see on the side here you have C and then 1 and 2, and you can select which one of them you want to operate. So for example, if I select K1, I can move the radio thing here, and I can turn on the radio itself. It doesn't have any signal. You can lower the volume if you want. But this one is actually hooked up to a text file in the data folder in app data. I'm going to turn it on. In the app data folder for reentry. And there's a text file that then can control radio stations that you can hook up with this device. This means that you can open that text file and you can have streams to your favorite internet radio stations, and you can give them what band it should be on, and then at what frequency, and then save that file and and when reentry then loads, it will connect the contents of this file with this radio. So this basically means that you can hook this up to a lot of radio stations. However, keep in mind that when I'm doing videos like this that goes on YouTube or streaming, then licensing on radio stations is a thing. So that's why I'm not able to show this right now, I think. Okay, I do think that that was most of the main systems. There's a lot of things under the hood, such as electricity system, the ECS system, and things like that, but I'm not going to go into all of the details in this video. But keep in mind that this is the re-entry implementation of Boctok, so Boctok-R is what I'm going to name it. It basically means that I do not have insights into how Boctok was operated in real. Some documents are available, most of them are in Russian. That's fine, but there's a lot of details that's not available. So this is just, you can basically call it a fictional recreation of what I think Boctok looked like, and my interpretation of the sources I have for operating this craft. But you can see that if you're playing other Vostok simulations, there's going to be differences on this panel. There's going to be a lot of differences on the indicator lights, and some even have added more panels here with attitude indicators and stuff like that. But this is my interpretation of it, and I try to keep it as realistic as I can. But of course, there's a catch when it comes to the information. Okay, so now I'm going to go into orbit view, and I'm going to time scale a little bit. And we're coming up on below Africa here, and we are going to prepare the entry procedures. There's not too much to it. We need to verify our orientation. We're still quite good. We can do something about the pitch. Oops, that was the wrong direction. You have these arrows here that could give you an indication of what direction to move the spacecraft to get into the correct attitude relative to the sun. But those values will be a little bit weird if you don't have the sun near you. But now they should be working. And I'm going to shut off that radio. Okay. And then I'm going to timescale a bit more. Since I'm in manual mode, the automatic retrograde system won't do the actual tests. The tests here is that it would align it 10 minutes before ignition. It would align the spacecraft with retrograde, and if it couldn't do that, then it will give you a warning, and you need to take over for manual. Right, and that's our cue. Entry is within 4 minutes, retrograde burn. So I'm going to mute that sound. And you can see that if I now unmute it, that signal light extinguishes. This means that we're close to retrograde, and that we need to, this one will get fired, or if you then switch down this one to off, it cancels the burn, and you need to do that manually, or I think recalculate it based on some emission parameters from mission control. Okay, we're now getting up to the day side. Once this engine ignites, you will be able to see the pressure here rapidly go down until it's sufficiently pressurized, and then it will get ignited. There's not a lot of pressure in that in it yet, so it's going to spend, I think it's about 2 seconds or something before the actual ignition happens because of that pressure difference. Okay, we're getting close. This is our cue. It's cooling down the instrumentation unit. We're waiting for this light. There we go. It's building up pressure and ignition. We can see that phase 3 has started. We can hear the engine noise, and we can see it from external view. You can see the pressure is decreasing slowly. And it's going to keep on burning for a predefined amount of time. Or if something fails, it's an automatic timer inside it that will cut it off after a maximum amount of burn time to make sure that you don't burn too much. And cut off. Now the instrumentation unit will automatically be separated, and we should there we have prepare to catapult. This means that we now staged from the instrumentation unit. The strap is open, and off goes everything. And what's left of us is this entry module here that will automatically stabilize since there's an offset of the center of gravity. It will automatically orientate itself so you're facing with like bottom way into the velocity of the entry, or the drag basically. Prepare to catapult. Let's verify this one. Always verify this. Keep in mind that this is, as mentioned, very early bits, so Boctok is still in a very early stage when it comes to a lot of these mechanics. You're already seeing that there's some light balancing that needs to be done, missions needs to be created, but most of all there's still quite a lot of work when it comes to the re-entry procedures, when it comes from kind of a mechanical perspective, which means, you know, getting through that atmosphere. There's some cutting of the visual aspects, and then of course the landing itself on Earth will need to be procedurally generated, but we're going to be landing in an area that basically looks something like this. It's a procedurally generated height map, but we'll see if it goes. It's very early, so that the entire re-entry procedure is unstable. Anything can basically happen, to put it that way. Who knows if our chutes will open, or if our ejection seat will get out of the spacecraft properly, or if even if we are going to get out of the ejection seat once we're out of the spacecraft. We'll see. It's exciting every time. It's brutally hard to create some of these things, and it takes quite a lot of time to actually test them. But here we go. I'm going to time scale until we're over this territory. Okay, we're now quite low on altitude, as you can see. The Earth is getting closer and closer. We're going to keep on time scaling. By the way, you can also see on the orbit indicator that we now 0.9 orbits into the mission. Our goal is 1.0, but that will happen on landing, so always back to time scaling. There we go. I stopped the time scale. You can see that we're now facing bottom first into the trajectory. This one will be burned off, but right now I haven't actually modeled the visual aspect of that. I do not know if you actually had to close this for entry. I don't think so, because I think the blinds are on the inside. And we're going all the way from orbital velocities, so this will take a few minutes. Of course, obviously, if you've been playing reentry before, Mercury and Gemini or Apollo, and you've done entry, you can see that the light inside of the cockpit is not affected from the outside. It should show some glow inside of the cockpit itself, and then of course that entire rumbling sound effect and the camera shake is also missing. I want to do some cool things with that, with some sound effects related to the bass and stuff like that, to just create a cool ambient feeling. But as I mentioned, this is scheduled for sometime after the 1.0 release of re-entry. So the main focus forward is still Apollo for version 0.8, and then some polishing and language support, typos, and fixing some missions in 0.9 before we even get to the 1.0 phase, among other things. Okay, we're getting closer. Okay, we're getting through. Okay, we're through the upper atmosphere. We need to double check our systems. No extra alarm. This one is the dangerous alarm. So what will happen now is that this hatch will blow off, and then we will catapult, and I'm going to do this first person view, but you can do this external view as well. There we go. And the chutes are out. There she goes, capsule. And we're on our way down. And this entire descent is quite slow. I haven't been focusing too much on this yet. I've been mostly doing systems. But eventually this seat should fall off, and we will descend through this cloud layer. So this last part will take a few minutes, and I'll just leave it running so you can get kind of the full experience for now. And I'm still playing around with this library for this volumetric clouds down here. It's very dense right now, and it will become quite dark clouds as we get closer and get through them. But that's configuration. Yeah, and I already notice a big difference between playing this in the Unity editor versus an exported exe, which I'm doing for the first time right now, I see that this one is falling down way too slow based on what I programmed it to. So I need to kind of identify that. It's probably something simple. Right, there goes the chair. It should have gone earlier, which means that we should now be on our main shoots. It's I haven't yet enabled two-sided layers on that yet, but that will come. Okay, we're getting through very close to that cloud layer. I'm just gonna run through this entire thing. Feel free to skip a little bit forward if you want to. Alright. Going through some dark clouds. As mentioned, this is a big test, and there's a lot of tweaking I can do with this library. But I think that they do look quite good. And if they work, I might even roll this out to Mercury, Gemini, and Apollo. Alright, getting through. And this shaking is also a floating point thing. It's fully possible to fix that. Alright. Getting through that dark test cloud layer. See how this looks. It's dark. And the reason this is so dark is the clipping range of the camera, for those who are into rendering here, of course. But yeah, the plan now is that this entire ground will be procedurally generated based on lookup data into height data of Earth, and as well as color coding for different biotops that we have, such as ocean, grass, highlands, mountains, and you can have different parameters to do that. I'm going to continue to leave this running to basically see what happens, and then end the video then. But well, while waiting for that, I'm probably just going to end the voice part of this and say thank you for watching. As mentioned, this is a very early build of Vostok. It's only available on my computer. It's not something that you can play if you get into reentry right now. But I do hope, based on the interests and based on the feedback I got from my previous demo of this on the 0.75 release, I've decided that I do want to kind of give this a polish, give this some more features, missions, and give it an academy after reentry has reached the 1.0 milestone. Then I'll continue to work on this and package this up as a module for reentry. There's a lot of fun things to do in that capsule. It's quite different than Mercury, but you do have those. Yeah, there you can see I've hit something. This is an invisible ground. Anyways, I think that there's a lot of fun stuff in that capsule. Basically, if I enable, for example, random failures, then you will need to shut that automatic system off for some of those things, and then tend to those and take manual control and do manual re-entries, things like that. But of course, that's for the future. Right now, I'm going to get back into Apollo development. I want to say thank you again for watching, and have a good afternoon.